All right, Unit 8, review. All right, number 1 says, okay, all the questions are going to be quadratic questions, except I think one question on here is not quadratic, and you'll have one question on your test that's not a quadratic question, but everything else is all going to be from Unit 8, okay? Number 1 says, the graph of quadratic function r is shown on the grid. What are the solutions to r of x equals 0? So in this problem, the word solutions is my key word, and solutions means x-intercept. So I'm looking at the x-axis, and I'm trying to find what are the two places that the graph crosses the x-axis. R of x equals 0, well, R of x is the same thing as y, okay? So when y equals 0, here's 0 on the y, what are my x-intercepts? Well, I have 1 here, and if you notice, it's counting by 2's, so 2, 4, 6, okay? So this is -2, -4, -6. So my x-intercepts are -6, 0, and +14, 0. Notice that my numbers are in the x spot of my ordered pair because it's the x-intercept. You can also see x-intercepts written as x equals -6 and x equals 14. That's another way that you could see them written. They could be written as x equals like this or as ordered pairs. Okay? Number 2. Quadratic function g is graphed on the same coordinate as the quadratic parent function. Okay, we've been talking about parent function, the original equation of f of x equals x squared. So this is my original, that's my parent, y equals x squared. It says if the vertex of the graph g is 10 units above the vertex of the graph in the parent function, what would be the function or the equation for the graph of g? Okay, so if you remember on our old notes, the part that shifts this up and down, okay, translates up or down is when we add or subtract to the back of our equation. Okay, so here's my parent function. If I want to translate it up, I say +5. If I want to translate an equation down, I say -5. So if I want to translate function g 10 units above the vertex, okay, if I want to move it 10 units up, I'm going to say y equals x squared, move it 10 up, plus 10. And that's my answer. Okay, number 3, factor. Okay, when you see the word x or factor, you think x factor. So I'm going to draw my x. Multiply and add. I'm going to get my calculator ready. I'm going to do first times last. So I'm going to do 3 times -8 is -24 on top. The bottom is going to be 23, the middle number, +23. Then I go to my graph and I do -24 divided by x. And I'm trying to find, Control T, trying to find two numbers that add together to get +23. 1 and -24 is -23. 2 and -12 is -10. 3 and -8 is -5. 4 and -6 is -2. 6 and -4 is +2. 8 and -3 is +5. 12 and -2 is +10. 24 and -1 is +23. So I have 24, -1. After doing my x, I'm going to draw my parentheses, x and x. I have a +24 and a -1. I also have this 3 out front, so I have to divide everything by 3. So 24 divided by 3 is 8, so x plus 8. -1 divided by 3 does not give me a whole number, so I'm going to take this 3 on the bottom and push it in front of the x. 3x minus 1. That's my answer. So if you don't feel comfortable doing x factor, you can always take your answer choices. It's all going to be multiple choice, okay? So you can also take your multiple choices and double distribute. Okay, and see once you double distribute which one gives you this part right here. Okay, so that's up to you. You can either X factor the problem, or you could double distribute your answer choices. Either one will work. Okay, number 4. What is the vertex? So my vertex is the highest or the lowest point. So here's the highest or the lowest. So what is the vertex of the graph of the quadratic function? F of x equals x squared plus 6x plus 10. So if I want to know the vertex, the highest or the lowest, I can't find that just by looking at this. I'm going to have to go graph it and find that point. So I'm going to go to my calculator, go to the graph, and I'm going to graph x squared plus 6x plus 10. Okay. To get my vertex, I'm going to hit trace, menu, 5, 1. It starts at the y-intercept, but I want the vertex. I'm going to go to the lowest point. My max or my minimum word is not popping up. Let's see. There's y-intercept pops up. Huh. The word minimum's not popping up. Is it popping up on y'all's, the word minimum? Huh? No? Okay, well my minimum, I can tell at the very bottom is -3, +1. So my vertex is -3, 1. I don't know why the word minimum's not popping up. Okay. All right, number 5. Write the roots of the quadratic function. Okay. Roots means x-intercept. Good. So I'm looking at my x-axis, and I want to know where does it cross my x-axis. Crosses here and here, which are -7, 0. Make sure you put that number in the x spot. And -3, 0. Remember, the other way you could write this is x equals -7 and x equals -3. Either one works. Number 6, the graph models A, the area in square feet of a rectangular porch with a length that is 0.56 W, less than 28 feet given a width of W. Based on the graph, what is the largest width in feet of the porch if it has an area of 300 feet? So what I want to know is based on the graph, what is the largest width? Okay, well here's width, and width is measuring my x numbers. Okay, so what is the largest width or the largest x in feet of the porch if it has an area? Area is measuring my y numbers. So 300 is going to represent y. So I want to know my largest x when y is 300. Well, here's 300. Here's my first dot and my second dot. Okay, where it crosses the 300. So what is my largest x? Well, my first x is 15. And my second x is 35. Which one's larger? 35. Questions on that? Okay, number 7. What are the solutions of 2 times x minus 11 squared equals 72? What solutions mean? X-intercept. How do I find x-intercept? You don't know? Graph. Okay. Now, before I graph, what do I have to do to this equation? I got to make it equal to 0. So if I want to make this equal to 0, how do I get rid of this 72? Subtract 72 from both sides. So these are going to cancel and equal 0. Over here, I'm going to have 2 parentheses x minus 11 squared minus 72. Okay, in order to find my x-intercepts, I'm going to go graph this. And I'm going to plug it in exactly how it looks. So 2 parentheses, x minus 11. Noah, are you watching this? Noah, put that away. This is the one that you were struggling on earlier, so you might need to watch to know how to do this. Okay? All right, so I've got a line. What is this line? Is it linear? Yes. Do I have a squared in my problem? I have squared, so can I have a linear line if I have squared? No. So what happened here? Can I see the other part of the U? Oh, no. No, I can only see one part of the U, okay? So what I'm going to do, you can either, if you want, if you don't trust me, you can zoom out and then you can see both parts of the U. Or you can go ahead and just do trace. And we're going to trace this, okay, to find our x-intercepts. So I'm going to go to the right, and I'm going to hold down that button until what word pops up? 0. Okay, so there's 0. My first x-intercept is 5, 0. Then I'm going to, oops, I can't see that I wrote that. Then I'm going to keep holding it down, and I'm going to go get my second x-intercept. See, there the word minimum popped up on that one. But I'm not looking for that. I don't know why it wasn't popping up on the other one. Okay, so then I'm going to keep going and get my second root solution, x-intercept 0. All those words mean the same thing. And my second 0 is 17, 0. Okay, or you could see x equals 5 and x equals 17. That's just another way to write it. Questions? Okay, look at number 8. What are the solutions to 2x squared minus 6x equals 56? How do I do this problem? Equal it to 0. Equal it to 0. So draw my line. How do I move the 56? Subtract. Does it have a like term on this side? No. Nope. So it doesn't matter where I write it. So I have 2x squared minus 6x minus 56 equals 0. Solutions means x-intercept. So in order to find x-intercepts, I have to graph it. So here we go. Oh, I didn't mean to do that. There we go. Okay, graph it exactly how it looks. 2x squared minus 6x minus 56. All right, these do not fall on a perfect dashed line, so I'm going to make sure I do trace on this one. Starts at my x-intercept. I'm going to go down. Oops. Starts at my y-intercept. My first 0. Uh-oh. I clicked too many times. Okay. There it is. My first 0. Okay. X equals negative 2.41. And then I'm going to go to the other 0. Takes a little bit of time, but you know for sure you're getting the right answer. My second 0 is x equals 5.41. Oh, you can't see that, sorry. Okay, questions on the first page. Okay, flip it over. Number 9. 9 says, determine if each statement is true or false. So the first one, the graphs of these two functions have a minimum point. So how would I know if these have a minimum? Okay, we're going to go ahead and just graph them so that I can look and see. Okay, we're going to graph each one of these. So I'm going to start with negative, control divide, 3 over 4, x squared plus 6, enter. There's my first graph. My second graph, hit tab, negative 2x squared minus 5. There's my second graph. Then I'm going to do the third graph. Tab, control divide for a fraction. 1 over 4, x squared plus 1. Okay, I've got all three graphs on here. It says the graphs of two of these functions have a minimum point. Okay, the blue line, is that a maximum or a minimum? It's a max. It's at the top of the blue line. The black line, is that a maximum or a minimum? Minimum. It's at the bottom of the black line. The red line down here, maximum or minimum? Maximum. So do two of these graphs have a minimum point? False. How many only have a minimum? 1. The graphs of all these functions have the same axis of symmetry. Do they all cut on the same line in half? Yes, that's true. The graphs of two of these functions do not cross the x-axis. So does this black line cross the x-axis? No. Does the blue line? Yes. Does the red line?
No.
Does not cross. So the graphs of two functions do not cross the x-axis. True or false? True. That works. Two do not cross the x-axis. Black and red do not cross the x-axis. Last one. The graphs of all these functions have different y-intercepts. Do they all cross the y-axis at different places? True or false? Do they all have different y-intercepts? Okay. Here's the y-intercept of the blue line. Does any of these other u's cross right here, the y-axis at this blue line? Here's the black line. Do any other lines cross the y-axis here? Here's the red line. Do any other lines cross the y-axis here? No. So they all have different y-intercepts. Is that true or false? True. They all have different y-intercepts. Okay, number 10. Graph each of the functions below. Okay, so for this, we're going to go graph one at a time in the calculator. Negative parentheses x plus 1 squared plus 4. I'm going to turn my grid on. And I'm just going to copy it. Okay, so my vertex is negative 1, 1, 2, 3, 4. So negative 1, 1, 2, 3, 4. Okay, I can see that there's another dot right here next to it, and a dot here. I have a x-intercept at 1 and an x-intercept at negative 3. Okay, so there's my first u. Okay, now I'm going to go graph the second one, which the only difference is a minus sign in between. So now I'm going to graph this one. I'm kind of putting the points where they go through in the corners on the graph. So my vertex is 1, 1, 2, 3, 4. 1, 1, 2, 3, 4. X-intercept of 3 and negative 1. Okay, there's my next graph. Okay, the third graph. Plus 1 minus 4. Okay, so now I have negative 1, 1, 2, 3, 4. So I'm going to go backwards 1, 1, 2, 3, 4. My vertex crosses the y here and here. Okay, these are going to be multiple choice problems. So you'll just have to graph the graph in the calculator to your multiple choice graphs. And then the last one, minus 1 and minus 4. Oops. I have, screwed this one all up. X minus 1, parentheses. And 1, 1, 2, 3, 4. Here and here. Like I said, you're not going to have to actually graph by hand on the test. These graphs will already be multiple choice answers for you. You just got to match them to the equation. Okay.